Hello students. Today we will discuss regarding binary trees. So first we are seeing a tree. Normally whenever we see any tree which is from down to upward, uh, in normal trees the root is at the downside as you can see in this diagram, and on the top of this there are branches and leaves. But if we talk about trees in computer science, so it is having a tree from top to downward. Like root is at the top, and all the branches and node are at the downside, as you can see in this diagram. So we will discuss the trees in this way, in which root is at the top and all the branches and node will be on the downward direction. So we are starting with a tree. What is a binary tree? Normally, we are discussing regarding binary tree in computer science because whenever we deal with computer science, so we have to talk normally in either true or false form, or we discuss uh, in the way in which we have either we can go in the left direction or we can go in the right direction. So here also in binary trees, it is a tree in which we can have at most two child of a particular node, that will be called a binary tree. So first we will see this definition and then we will move further to see the tree. So a binary tree is a finite set of elements that is either empty or is partitioned into three disjoint subsets. The first subset contains a single element called the root of a tree, and the other two subset are themselves binary trees, like you can see in this picture. So here the element which is present at the top of the tree is called a root of the tree, and it has a left subtree and it has a right subtree. So uh, as we are seeing in this definition, the first subset contains a single element. This is called a root of the tree, and the other two subsets are themselves binary trees, which is called left and the right subtrees of the original tree. So a left or a right subtree can be empty. Each element of a tree is called a node of the tree. So the left or the right subtree can be empty. Our tree can also have a single element which is called a root, or it can have any number of elements, and every element of a binary tree is called a node of a tree. So first we will see the part of tree, then we will move further to see it in the form of diagram, right? So what are the parts of a tree? A binary tree is composed of zero or more nodes, as we discussed now. A binary tree may be empty, which means it may not have any element, or otherwise if a tree is not empty, then definitely uh, a binary tree will have a root node. So a node with neither a left child or a right child is called a leaf node. So we will see all these terminologies in the form of a diagram. Uh, so this is a picture of a binary tree in which A, which is present at the top of the tree, and it has no further parent. So this is called a root of the tree, and other elements are the part of the tree, or we can say that all the elements, these are the nodes of the tree, and this part is the left subtree, and this is the right subtree of a binary tree. So this is basically the abstract tree model. But otherwise, if we see it in more detailed way, actually our tree is stored in memory in this fashion. Like it is implemented inside any programming language in the form of linked list, where uh, every node is maintained in this way, which means it has an information part where the information is stored, and it has a two link part. One is the left part and second is the right part. left part contain the address of the left node, and the right part contain the address of the right node. Similarly, these nodes can further contain the addresses of left and right nodes. Right. Then you can see this diagram also. Here A is the root of the tree, and A is also the parent of B and C, and A is the ancestor of all the other nodes. B and C, or we can say that any two nodes, any two or more nodes which are having the same parent is called the sibling. Here we can see that B and C are having a single parent, having a same parent, that is A. So we call B and C are a sibling, right? So any two nodes which are having a same parent will be called as a sibling, and in this case, D and E are the child of B node, and other nodes like H, I, J, or K all are the leaf nodes, or similarly L, M, N, and O, these are the leaf nodes. So what is a leaf node? Any node which don't have any further child is called a leaf node. So all these nodes which are present at the last level doesn't have any further child, so we call these nodes as a leaf nodes. And here J and K will be called as the descendant of node B, because these are the grandchild of node B. Similarly, H and I are also called as a descendant of node B, because these are also the grandchild of node B. So the edges which are present from one node to other node, or the links which are present from one node to other node, are called a edge. And similarly, uh, any two nodes which are at the same level, like B and C are at the same level, so we call this as these nodes will be present at the same level. Like A is present at the level 0, B and C are present at the level 1, D, E, F, and G, these are present at the level 2, and similarly these all nodes are present at the level 3. So now we are checking some structures which are not binary trees, because we know that tree is a cyclic in a nature. So in tree, cycle is not present, but here you can see that there is a cycle in a tree. So this is not a binary tree. Similarly, again, cycle is present here, so this is also not a binary tree. Again, cycle is present here, so this is again not a binary tree. So normally trees are cyclic in a nature, but in a graph there may be a cycle. Then we have a size and a depth. So what is the size? The size of a binary tree is the number of nodes in it. Like in this tree we have a total 12 nodes. You can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So total 12 nodes are present in this tree. So the size of this tree will be 12. The depth of a node. So what is the depth of a node? The depth of a node is it's a distance from the root. So, like if we talk about the depth of A, so the depth of A from A is a 0, because A itself is a root node. And if we talk about E, so the depth of E is 2, because the distance of E from the root node A is 2. Distance means the number of links or the number of edges present from a node to the root node. So here from root node A to E, there are two edges present. So it means the depth of the node E is 2. Next is the height. The height of a binary tree is the depth of its deepest node. Means its deepest node is I. So it is present at the depth of 1, 2, 3, and 4. So the depth of the deepest node of a tree is called the height of the tree. So it means the height of this tree is 4. or you can see that you can say that the distance from the root node to its farthest node is the height of the tree. So the node which is present at the farthest location, and the number of edges from the root node to that particular node will be the height of the tree. So in this case, the height of the tree is 4. Then what is the maximum number of nodes at present at some level or some depth, say L. So if we need to find uh, that what are the maximum number of nodes which can be present at any level, so that will be 2 raised to power L. If L is the level or L is the depth of a tree at any particular location, then the maximum number of nodes at that particular level will be 2 raised to power L. Like you can see in this diagram also. So if we need to check the maximum number of nodes at this level 2, so maximum number of node can be present is 4, because 2 raised to power 2 is 4, and you can see that all the possible nodes are present here. No further node can be present at this level 2. So with this formula we can find the maximum number of nodes at any particular level. Then what will be the height of a binary tree? So maximum height of a tree for n nodes. So if we have n nodes, and uh, from these n nodes we can tell the maximum height of a binary tree. So maximum height can be n minus 1. In that case, the tree will look in this way, like it can be left heavy, like in this way, because here we have a 4 nodes, you can see that, but the height is 3. This is the maximum height that we can uh, see with these number of nodes. Similarly, the minimum height of a tree, the minimum height will be log n. Means if the tree is fully filled, like you can see in this diagram, in this diagram. So in this case, the height is showing uh, log n, like that we have discussed here. The minimum height of a tree is log n. So if we have n nodes, then the height minimum height will be log n. So if we have these 15 nodes, so minimum height will be 3. So here you can see that this is a tree having a height 3, and with the 15 nodes, this minimum height can be possible. We cannot achieve less height than 3 in case of 15 nodes. So in case of n nodes, the minimum height will be log n. And last, if we know the height of a tree, then definitely we can also tell the number of node present. So if the height is h, then minimum number of node will be h plus 1, and maximum number of nodes will be 2 raised to power h plus 1 minus 1. So with this we can find the number of minimum nodes and number of maximum nodes. Thank you.